Okay, we can start, see if anybody will join in a little bit. So tonight we're talking about equivalent expressions. We'll talk more about that when we get to it, but let's just start out with our challenge problems. So number one, this one is actually really, really challenging. So I'm gonna make a little coordinate plane here. And it says that this first line intersects the y-axis at 0, 10, and it's parallel to line G, and line G is y equals 4x plus b. Well, if it's parallel, that means it has the same slope, and this 0, 10 is its y-intercept. So the equation for line F is y equals 4x plus 10. And then the equation for line G they're giving us is y equals 4x plus, let's say, b, right? So they're not giving us b. And so what we want to do is I'm going to kind of just like graph those, see what they look like. So real quick, 4x plus 10 would just have like a y-intercept of 10 and have like a positive slope. So again, I don't really care too much what it looks like, just so we can get a little bit of a visual. And then 4x plus b, where b is less than 10. So let's just say that's here. And we know that it's parallel. And then it's saying at x equals k. So x equals k is just some x value. So let's just pretend that it's right there. It doesn't really matter where I put it. This is just where I would like to put it. And it says um, the distance from the x-axis to line G. So this one's G and this one's F. It's saying that, let me use different colors here. So it's saying that the distance from the x-axis to line G is equal to the distance of from line G to line F. So even though they don't look it because of how I drew it, those two distances are supposed to be the same. The red distance should equal the green distance. And they want to know what's the value of K. And clearly, at least if we look at most of our answers, there's going to be like a B in there. So this is kind of how we're going to do it. The way you would find a vertical distance is you would just plug that value into whatever the graph was. So for instance, this distance here would be whatever we get when we plug k into this equation. So that would be 4k plus b. Okay, because this height is like a y value, and I get the y value by plugging in the x value, and the x value is k. So this represents this distance. Okay. And then if I also plug k into this one, that's going to give me 4k plus 10. But that is this whole distance. That is going from k all the way up to here. But this is really just half of that distance. All right. So this distance here, the purple distance, is just half of this. So that's 2k plus 5. I said this is a really hard problem. So this one is quite a lot of work. And then you would just set these equal to each other because they say that they're equal. So 2k plus 5 equals 4k plus b. And they want the value of k. So I would just solve for k. So I would subtract 2k from each side. So if I take 2k from over here, that's 2k plus b. And then if I want to get k by itself, I would subtract b. So I would get 5 minus b equals 2k. And finally, if I get k by itself, I would divide by 2. and I'd get 5 minus b over 2, which is what they're looking for. So as I said, that is a super, super challenging problem. Let me know if you have any like questions about any of that.
I'm good, thank you.
Okay. Okay. All right. Number two. This one's still hard, but a little easier. So we've got this is called conditional probability. So I'm going to kind of skip ahead to the question actually. So it says, given that a shirt landed in sector G, that's called conditional probability. So it really means only look at that part of the table. So if it landed in sector G, I only care about this part of the table. So everything else is just there to distract us. And it says the probability of it being blue is 1/3. So the way that you would find the probability is it would be the number that it's blue, which is 20, over the total. Well, they don't give us the total, but the total we get by adding these together. And that's 20 plus x plus 4, which is 24 plus x. So I have 24 plus x on the bottom. And then we know they tell us that that probability has to be equal to 1/3. You might be able to figure this out, but if not, you just cross multiply. So 3 times 20 is 60. And 1 times 24 plus x is 24 plus x. And finally, you just subtract 24 from each side, and you're going to get 36. You could also, I guess, look at it as if the probability is going to be 1/3 and you know this is 20, then you might be able to figure out, well, then this must be 60 because 20 times 3 is 60. And then you could just get x is 36 that way. So it's a couple different ways to go about it. Okay. I'm just going to keep moving. If you have any questions at all, just stop me and let me know.
Okay.
But we are going to move on to one of the major like topics, especially on the new digital SAT, is this idea called equivalent expressions. And all it really is it tests a lot of different math, a lot of different like factoring and FOIL and distribution and all kinds of different ways, exponent laws, as we'll see. And it's basically the idea of every problem is they give you some expression and they want to know which expression is the same as that expression. Um, so we should always know the like all of the maths, let's say. Like we should know how to distribute, we should know how to combine like terms. And then once we know all of that, we then want to be able to take shortcuts. So a lot of tonight, what I want to go over is essentially how can we use the answers and the actual math, but just doing pieces of it to get the answer. So one way to do that would be to first understand that the first thing, if we were doing this in school to solve this problem, would be we would want to distribute this negative 20. But again, if we do that and then combine like terms, that's going to take some time. So what I would do is try to isolate just pieces of it. So imagine I only did the last one. That would be negative 20 times negative 1. So I would get a term, and then I would get a plus 20. And then imagine that I combine like terms. Well, that would be the term that combines with this. And that is going to combine negative 150 plus 20 is negative 130. And the only answer that has that is D. All right. So again, it's a shortcut, but it's not like you still have to understand the math to do the shortcut. If you do the negative 20 times these and combine it, you'll certainly get these. Um, But if you just isolate the constant, a lot of times I'm either going to isolate the constant or maybe the first term. I don't know. It just depends on the problem. But I just saw that really quickly. Like this would give me 20 and negative 50. And if I just do that first, I get the answer. Okay, so the hope is that we know how to simplify this whole thing, and then we can just only focus on a piece of it and a piece of the answers, and then that allows us to, figure out the answer a little more quickly. All right. Number two is actually not an example of that. Number two, we just have to be able to, this is just another big thing, is just knowing the exponent laws. So again, couple different ways to do this. I could just subtract my exponents. Whenever you're dividing, you subtract. So what I would do is do -1 minus -2, or just use a calculator for that to make sure you don't make a mistake. But that is -1 plus 2, which is 1. So the exponent on x is x to the first. I'll write it like that. And then when I do y squared and y cubed, I'm subtracting. That's 2 minus 3. So that's y. 2 minus 3 is -1. And then we should also know that y to the -1 means it could go to the bottom as y to the first. So it would just be d. Or, right when we're at this step, hopefully we just know that that's d. So a negative exponent goes to the bottom and becomes a positive exponent. And when you're dividing, you just subtract your exponents. All right, so exponent laws are definitely something that we have to know for these types of problems, at least for some of them. Okay. All right. This one is interesting because I'm going to do it the way that we would do it in school, and we're going to actually see that that answer is not there. Um, So they can really kind of take some liberties here when they're doing this idea of equivalent expression. Because when you do it in school, you're used to like you need to give the most simplified answer. And there's kind of rules that make sure that everybody's answer ends up being the same. We kind of have rules that tell us what makes something simplified. Um, but there are a bunch of other stops along the way that it might not be simplified, but it's still considered equivalent. So they do that, and it makes it kind of tricky to do these problems sometimes. But I'll show you what we can do here. So we're just going to pretend that this is a school problem. So the first thing you would want to do here is when you're factoring something is look for a GCF. So notice that they all have a 4x in it. So then this one becomes 4x cubed, and this one becomes 2x squared. And this one becomes minus 6x, and then this one becomes minus 3. And then whenever you have four terms, you're going to do factor by grouping. So I have this 4x just hanging out here, right? And it makes me think that one of these is the answer. But this is why this kind of problem, it gets a little confusing for students that are just used to doing it this way in school, right? So you do factor by grouping, you take out a 2x squared from here. And then you're left with 2x plus 1. And then you remove a -3 from here. You're left with 2x plus 1. Everything seems like it's going well. We end up with a 4x. And then we have a 2x squared minus 3. And then we have a 2x plus 1, the thing that have in common. So again, if this were school and you were given an expression and said factor completely, this would be your answer. Everybody in the class, there would just be one answer and everybody's would look the same. But if we look, this answer is not here. Okay. Um, this one has a 2x squared minus 3, but it has a 2x minus 1, not a 2x plus 1. So that's wrong. And then this one has a 2x plus 3, not not a 2x plus 1. So that's wrong. So the ones where you took out a 4x is not the thing they wanted us to do. But the thing is that we can also rule out A because we have a 2x plus 1 and a 2x squared minus 3, and we have something else out here. So A doesn't make any sense. So the answer must be B. So, like, even though we did everything correctly the way we do in school, that answer is just not there. Where they got this answer from was they just factored out an X, which you would never do in school because the X is just a common factor. It's not the greatest common factor. And you're always supposed to take out the greatest common factor. But again, they're getting away with this because this is still an equivalent expression. It's just not the most simplified form. So it's something you just have to look out for. They ask these types of questions and you have to be able to just logically figure out. So one way to do that is to just do the way what you would do in school and just start getting rid of answers that don't match that or just that couldn't possibly be it. Because it'd be really hard to just know that we should have factored out an X. So it's kind of like one of the only ways that we could get to this answer. All right. So they're taking a really easy concept of factoring and then making it even harder by factoring out an X instead of a 4X.
Okay. I have a question as to why when you factor by four that you have to do by grouping.
Oh, so that's just so like when there's different like there's different methods of factoring, and whenever there's four terms, that's just the method that typically works. Um, Other methods are when there's like a trinomial. I don't know, make one up. Like let's say you had x squared minus 5x minus 6. So like these, when you have a trinomial, typically you try to do it like this. Like you do like x and x, and you find two numbers that multiply to -6 and add to -5.
Yeah.
So you just have to know that when there's three terms, you're going to look to factor kind of like this way or use what's called like the AC method you might have learned. But yeah, whenever there's four terms, it's just like that's the method you would try.
Okay.
Yeah, so it's just something to know. When you see four terms, you just got to think factor by grouping. And honestly, for the SAT, that's what it would be. The only times it wouldn't be that would be like probably like in pre-calc or higher, where you would have like other ways that it could factor. But yeah, if you see four terms on an SAT problem, you're going to do it this way, factor by grouping. Okay, so let's take a look at number 4. All right, so here is a problem that I do not want to multiply. I don't want to have to multiply all this out. If we were going to, there would be six terms. I would do 4x squared times each of these, and then negative ax times each of these, and then 1 times each of these. And I would get six terms. And again, that would take some time. So, what I'm looking to do is use my knowledge of how I would do that. Like, I have to know how to do that to then, like, look at the little pieces that I want to do. So, the first piece that I would want to do is this one. That would give me 4b x cubed. And that is the only term that's going to give me x cubed. So I know that that's this. All right. So if I were to start this problem, I know that that's it. Because if you look, there's no other term that's going to give me x cubed when I multiply. Right. So I got to know that there are six multiplications that I would do, but I'm trying not to do all of them. So I'm starting with the very first one. So that tells me that b has to equal 7 because 7 times 4 is 28. And it's the only way that I'm going to get 28x cubed is if I make b equal to 7. So that's the way that I get 7 without doing a lot of work. Um, okay. So now I'm going to imagine that this is a 7. I'll just get rid of the whole thing and I'll say it like this. Okay. So that's now like a 7x instead of a bx. Now I have two options. I'm either going to focus on the x squared term or the x term. I'm just going to choose the x squared term. So look at my 19x squared. Actually, I can use a different color. So we look at the 19x squared. I'm going to pick out the combinations that would give me x squared. And that would be 4x squared times negative 3. That gives me negative 12x squared. And then the only other combination that will give me x squared would be negative ax times this 7x. That'll be negative 7ax squared. All right. So again, I'm imagining in school I'd have to do all six multiplications, but I don't want to have to do all of them. So I only choose these two because I know these two have to combine to give me 19x squared. So these have to equal 19x squared. Because all the other ones that I multiply out are not going to have an x squared in them. So I don't have to worry about them if I'm only focused on the 19x squared right now. And then I could just imagine the x squareds just go away, and I have negative 12 minus 7a would have to equal 19. Uh, Hold on, I think I made a mistake. Hmm. Because a is supposed to be that night. Oh, this 19 is minus. That's my fault. I missed the minus back here. Okay, now we're back on track. Yeah, because now when I add 12, I get negative 7. Now when I divide by negative 7, it tells me a is 1. And then finally, it wants a plus b. So a plus b is going to be 8. You could have done it with the 10x. You could have just multiplied only the terms that would have given you an x and made that equal to 10x. So you could have picked either one. If you want to, you can just do all the multiplication out if that's easier for you to see. Just trying to show like another way where you don't have to do all of the work. You just kind of pick out the pieces that you think you would need to get the answer.
Okay.
Okay, so that will make sense then.
Yeah.
Good. Okay. Number 5, back to exponent laws. So it just wants to know the product of these. So I'm just multiplying them. This might look complicated, but imagine if you were to have a problem that looked like this, we would know right away that we're supposed to distribute. So the same thing is happening here. We're multiplying this by this, which has an addition. So this has to get multiplied here, and then it has to get multiplied here. So again, I'm going to try to do it in a shorter way, but I don't think it's going to work, and I'll show you why. So what I would do first is just do the first multiplication. So I'm multiplying this term by this piece before the plus sign. And when I multiply, I'm using exponent laws. And I'm adding my exponents because when you multiply, you add your exponents. So the b to the 6th times the b to the 8th is going to give me b to the 14th. And the c to the negative 2 times c to the negative 3 is going to give me c to the negative 5. And then the d to the negative 5, imagine there's just like a 1 here. That would just be also d to the negative 5. So that's going to be my first term. So I'm going to have that plus something. Now, what I want to do is I want to go through and hope that I only have one answer left. I don't, but I can at least get rid of these two because they don't have the d to the negative 5 in it like they're supposed to. But unfortunately, both of these do. So I can't get away with just doing part of the problem. I'm actually going to have to do the whole thing. So then I just go back and do it again. B to the 6th. Well, there's no b here. So there's just a b to the 6th. I probably could stop there because there's a b to the 6th, but just to finish it, c to the negative 2 times c to the 4. Well, negative 2 plus 4 is 2. And then d to the negative 5 and d to the 5th. Well, negative 5 plus 5 is 0. And another thing we should know is that anything to the zero power is one. So that is just not there. So again, the answer is C. So the reality is once we did the b to the six, once we knew that was there, like we knew the answer was C, we could have stopped there. All right, so it's just like a harder version of a distributive property problem with exponent laws. Okay. All right, six is an equivalent expression, or actually, this is an equivalent equation, but they'll still include it in equivalent expressions. And it's related to, I guess it was 2 weeks ago, or no, was it last week we did quadratics? Last week or the week before. So whenever we did quadratics, there were multiple forms that we talked about. So this is in standard form. And when they say this kind of strange sentence, it's like it includes the x and y coordinates of the vertex as constants or coefficients. That is just them saying they want the answer in vertex form. Well, unfortunately, they're all in vertex form. Vertex form is like this. So we should know the forms of the quadratic. Some of these they have some that aren't even in vertex form, and then you can just get rid of them. But this one we can't, unfortunately. Um, okay, so basically we have to figure out which one of these is equivalent to this. The long way to do it is to take, and how you would do it in school is you would take standard form and you would have to convert it to vertex form, and that involves completing the square and factoring out this two. It's a lot of work. We should know how to complete the square for other problems, but for this one, I wouldn't do that. What I would do is I would figure out which I would use all the answers kind of at the same time to figure out which one is going to give me this. And I think the quickest way I could think of doing this was to just focus on the 11. So if you look at A, I'm going to actually write it down here. The long way of doing this would be to actually square this out. Hopefully, we know if you really have to, you got to do x plus 2 times x plus 2 and do FOIL, but it'll be x squared plus 4x plus 4 plus 3. I am not gonna, this is not how I would normally do it. I just wanted to show you where like the kind of the shortcut comes from. The constant is just going to be this 4 plus 3. Well, I could have figured out the constant without doing that. I could have just done 2 squared because I don't really care what the x's are going to end up being. I only want to focus on the 11. So again, 2 squared is 4, 4 plus 3 is 7, so that answer is wrong. And if I do the same thing here, 2 squared is 4 and 4 plus 5 is 9, so that answer is wrong. Now, if I get 11, I wouldn't be able to say that's the correct answer yet. I'd have to eliminate 3 of them. So now this one, there's this 2 in front. So whatever I get for the constant will have to also be multiplied by the 2 because that 2 would eventually have to get distributed, right? So I'm trying to just focus on the constant. So this will be 2 squared is 4. That 4 would get multiplied by this 2, which is 8, and 8 plus 3 is 11. So what I would do is I would put a little check mark here. I wouldn't say it's definitely the answer because sometimes like the a wrong answer could look like a right answer. But if I do it here, 2 squared is 4, 4 times 2 is 8, and 8 plus 5 is 13, not 11. So since 3 of them are definitely wrong, this one must be the right answer. All right, so again, we get it by just focusing on one part of it. But that part doesn't really make sense if you don't understand kind of how to do it the longer way. So then you can like take shortcuts. Okay. Any questions?
No, that one makes sense.
All right, good. All right. Number seven. I don't think I really found a shortcut on this one. This one you just gotta kind of do, but it doesn't take that long. So the first thing I would do is in the numerator up here, we have to add fractions. Well, anytime you add fractions, you want to get a common denominator. So the common denominator is going to be x times y. So I want to multiply this one by y over y, and I want to multiply this one by x over x. So y times 1 is y, plus x times 1 is x. So I get y plus x over xy. That's what this is equal to. And now that's all over z. And I'm going to think of that as z over 1. Because what I want to do is I want to, like, when something looks different than what you're used to, just make it look like something that you are used to. And hopefully we know how to divide fractions. And usually when you're dividing fractions, at some point we've all learned keep, change, flip. So what you need is two fractions. So you keep this fraction. So that's y plus x over xy. You change it to multiplication and you flip this fraction. That's why it's easier to think about it as z over 1. So it's easier to flip in our head to be 1 over z. And then if I just multiply straight across, I'm going to get y plus x times 1, which is y plus x, and then I'm going to get x, y, z, and that is this answer. So I don't really see much of a shortcut there. We just got to kind of do it. But the thing here is a lot of times when I'm doing this with students, they get confused about like what to do with that z. So just think about it as dividing fractions, and when something's not a fraction and you want it to be, just put it over 1 and then just do what you would normally do. Okay, number 8. All right. So this is some like radical exponent laws combined with asking a question in a much different way again than what we're used to in school. So in school, we might have a problem like this where they just say to simplify. And then they add this extra like it's equivalent to this. Well, what I would do when you see stuff like that, just ignore it at first. Just just realize that when you do solve this, it's eventually going to look like this. So just ignore that at first, and we'll get to it. So just attack this problem with we just have to know how to simplify this. So I have an 8 times. Now, if I do the cube root of 27, we either know that's 3 or just use a calculator to get that. And then when you're doing the cube root of x to the 81, the way you're going to look at that is you say, how many times does 3 go into 81? And it goes in 27 times. Again, you could use a calculator, just do 81 divided by 3. So that first one gives me 8 times 3, x to the 27. And we'll multiply these. I'm just going to wait until the next one. So now here, I want to do the seventh root of 2 to the 14. Well, again, I can just say 7 goes into 14 twice. So I get 2 to the second power. And 7 goes into 21 3 times. So I get x to the third power. And then I just keep going. I say, all right, 8 times 3, 2 squared is 4. So 8 times 3 times 4 is 96. And then when I multiply these two together, I'm just doing adding exponents, and I get x to the 30th. Now notice it is in that form. All right, so just by solving the problem, I think a lot of times students see this and they think they should know what to do with that right away, but you don't. Now I know that k is 96 and m is 30. So a lot of these equivalent expression problems, you're just making something look like a form and then just like matching up what these other like constants are. And then it just wants k over m in simplest fractions. So either reduce it, use the TI-84, like 90 divided by 30, and if you hit like math, enter, enter, it reduces it for you. You could also put this in Desmos, and there's a fraction button on the left. That'll reduce it. Either way, we should get 16 over 5 once we reduce it. Okay. Number 9. Um, all right. So this one I would do, um, I would kind of attack this from both directions. So the first thing I would do is it wants to know which one is equivalent to this. So I would actually just figure out what that is. So I would do x minus 2 over x. Whoops, that's not what I wanted to do. If it's squared, then I want to multiply it by itself. So I'm going to do, and then you're just going to look at it as like FOIL. So you do x times x is x squared, and then x times negative 2 over x. Well, if you think about what that is, x times negative 2 over x, the x's cancel, and you're just left with negative 2. And then when you do negative 2 over x times this x, the same thing happens. And then negative 2 over x times negative 2 over x is positive 4 over x squared. So you end up with x squared minus 4 plus 4 over x squared. All right, so that is what we're trying to match. Then notice that every answer has this in it. So I'm going to just figure out what that is. So x plus 2 over x times x plus 2 over x. And again, do FOIL. So x times x is x squared. X times 2 over x, that's positive 2. And 2 over x times x, that's another positive 2. And then 2 over x times 2 over x is a 4 over x squared. And finally, I get x squared plus 4 over x squared. So basically, what's happening is I need to take my answers and figure out which one is going to give me this. Well, they're all starting with this. Like the first part of all of these are all this thing, right? And I'm basically only adding or subtracting a number from that. So if I want to go from here to here, the only thing I really care about is I'm starting at 4 and I want to get to negative 4. Well, the only way that's going to work is if I start at 4, if I subtract 8, then that's going to get me to negative 4. So that's going to be A. So it's just a way you kind of do the one and then you work backwards from the answers. But instead of doing each answer individually, take the part that every answer has in common and just do that part because you're going to have to do that for each of them anyway. So instead of repeating that, I mean, this one we would get lucky if we did that because it would be answer choice A, but that could still, if it were D, it would have taken us a while. Um, Also, just to mention, this took a long time regardless. When you have equivalent expression problems, if you are ever forget maybe like a math concept or whatever is necessary to solve that problem, there always is Desmos. I would put this expression in like the first line of Desmos, and then I would put the first answer in the second line. And if the graph lies completely on top of the other one, then you know you found the answer. So you would just go through each answer to see which one is on top. This might be a good problem for that actually, because it did take a while. So it might take less time to just like type this into Desmos. But there are some equivalent expression problems where typing in the Desmos would just be a lot of extra time than just like doing it straight away. Okay.
Okay.
All right. Again, this is one. If you look at this and you're confused, don't think twice. Just use Desmos. It's not the quickest way. I'm going to show you the little bit of a shortcut. But if you see something like this equivalent expression, and it doesn't have all those like constants in it like it did in the other problems, you would just throw this into Desmos and then start doing each answer and figure out which answer. Yeah, yeah, and just figure out which answer, like which graph lies directly on top of the original. Um, but there's a quicker way. So this one is related to, I'm going to choose different letters. I'm actually going to choose A plus B. So I want you to see this. If we usually see this with X and Y, but I don't want to confuse it with everything that's going on up here. If you were to do A plus B squared, the long way would be to do A plus B times A plus B, and you would do FOIL. And you would get, we did it on a couple problems earlier. So you would get A times A is A squared. Then you would get A times B is AB, and B times A is another AB, and B times B is B squared. And then you would get A squared plus 2AB plus B squared. So this is kind of like a formula that you can square things using this. So it's the first one squared and then double the multiplied together and then the second one squared. Okay, that's what's actually going on here. So notice this. This is like a squared plus 2ab plus b squared. I can put the squares here. Which means this is the same as a plus b quantity squared, where a is x plus 1 and b is y plus 1. And that's x plus y plus 2, which is answer choice B. So just recognizing that that is a plus b squared or whatever you want to, whatever letters you would have learned it with. But that's like the shortcut for squaring this. Instead of doing FOIL, you just go right to a squared plus 2ab plus b squared. And recognizing that and working backwards is, again, like a super quick way to do that. But if you don't recognize that, it's fine. This is one where I wouldn't like actually multiply all this out. It would take way too long. If you don't recognize that, this is another one where just like use Desmos to help you on those problems. But like I said, if you recognize this, then you can get the answer like really quickly. Okay. Um, let's move on to number 11. Okay. All right, this one's pretty tricky. So the first thing I would look for is these are equivalent. They say it can be rewritten, just a fancier way of saying that they're equivalent expressions. And one thing I could do over here is FOIL. There's not much I can do over here. I can't factor it because I don't know C. So I'm going to go and just FOIL. So this is ABX squared. And then this is minus 5AX. And then this is plus 5bx. And then this is minus 25. And they're telling me that that can be rewritten as cx squared. So that's this. And then 15x, that's going to be these. And then minus 25. Well, minus 25 is just matches up with that. So if I look at this, well, this isn't helpful because I don't know C. So if I don't know C, I'm definitely not going to go A times B. So I need to focus on this middle part. So when I do negative 5ax plus 5bx, that has to combine to 15x. All right. Because again, if I match everything up, I know that the negative 25s go together, and I know that the x squareds go together. So these are going to have to go together. The x's all divide out, but it still seems like I don't have enough information because I have one equation with two unknowns. But if I imagine this like this, if I instead of negative 5a plus 5b, I imagine it as 5b minus 5a, and they want me to get the value of b minus a, when they ask for an expression of different variables or constants, there's a way to get there without finding each one individually. And this one we can get there just by dividing everything by 5. So if I do that, I get b minus a equals 15 divided by 5 is 3. And that's what they want. They want the value of b minus a. So the answer is 3. We never actually find b or a. We just get to the point where we figure out that b minus a is 3. And you wouldn't think of doing that right away. You need a way to get started in these problems. So the way to get started is to just do FOIL. And then you start to like match up what has A and B in it. You ignore the C. And then you have to kind of get clever and realize that you just have to like rearrange it a little bit to get the value that they're looking for. So it's definitely a pretty hard problem. Okay, let's move on to the last one. All right, so we've got this expression is equivalent to this, and we want the value of p. So let's not worry about this right now. Um, we'll get it in that form, and then we'll worry about it. So we want to simplify this, but they also tell us that b equals a. So that means I can either make A B or make B A. Well, I want to make sure that I still have an A in my problem because they want me to have an A over here. So I'm going to replace this B with A. So I have A to the 3 over 2 times A to the 1 over 3. Right? So that might seem obvious, but if you were to accidentally just put a B over here, it wouldn't look like this. All right? So we want to get rid of the B because it's not part of what we're trying to make it equivalent to. So now what I have is an exponent law where I have to add these. So I have to add 3 over 2 plus 1 over 3. Either just do that in Desmos or a calculator, or just quickly get a common denominator. So I'm going to multiply this one by 3 over 3 and this one by 2 over 2. So I get 9 over 6 plus 2 over 6, and that gives me 11 over 6. So I have A to the 11 over 6. Now they want us to write it in this form. Well, that is radical form, and right now it's in exponential form. So the way that you write something from radical form to exponential form is the numerator is the power, and the denominator is the root. So when I write it in radical form, this is the sixth root of a to the 11th. So now when we match it up with this, and they want the value of p, that is just they call it the index there. That is 6. So the answer to the problem, the value of p, would just be 6. All right. So it's a bunch of exponent laws combined with, again, them like writing it in a strange way and then just asking you the value of this kind of like random constant that they just like threw in there. Okay. Any questions on any of the problems that we did?
No.
Okay, good. All right, well then we will stop there. So I will email out Thursday with the link for the YouTube and the answer key, and then the problems for next Monday. So thanks for coming, and hopefully I'll see you same time next Monday.
Thank you.
You're
Have
welcome.
a good night.
Thank you too.